Hello everyone, I'm Vinayak Koppad. In this video, I'm going to explain you the problem of pentagonal pyramid that is resting on one of its slant edge. Okay, first we shall look at the problem. A pentagonal pyramid 25 mm sides of base and 50 mm axis length rests on HP on one of its slant edges. Draw the projection of the pyramid when the axis appears to be inclined to VP at 45 degree. Okay, let's start the solution here. Open the solid edge ST7 software and write down the XY line, VP and HP. Then go for a polygon by center option. Select the number of sides as 5 and go for vertex. Here we have to place the base of the pyramid in such a way that the corner should be towards right of you. And here in the problem it is given that how much it is, 25 mm sides. Okay, so 25. Yes, sometimes again you may face this kind of problem. In that case, so you can go for this method, so by midpoint method. So first you can draw it like this, go for smart dimension. So this is 25. After this, so you can rotate this one. Rotate, I want to rotate this, just this way you can rotate it. Now you can place the base at the proper position. Now you can show the dimension, and again we need to find out the midpoint here from the corner to the opposite line of the midpoint. So we need to connect it. So like that you just do it for any two from the two corners, then delete it the remaining and join from all the corners to that midpoint, because in the pyramid when you look at the top all the edges are visible here. Now go for the annotations. So give the annotation A, B, C, D, and finally this is E, and here it is O, and within the bracket it is O1. Now project from all these corners to VP. And just remove the unwanted or the extra projections. 0.05. Now in the problem it is given that height is 50 mm, right? So this will be the axis, 50 mm line, vertical line we have to draw it, and from the all these corners connect to the apex point. Now connect the bottom one also, and you can change this axis line type, that is the third one. Now use the annotation and write down the properly the annotation, that is B dash, within the bracket it is A dash because it is not visible when we are looking from the front side. So dash is not typed here, just type the dash. Yes, now again take a here, so this will be the O1 because again we have to write within the bracket, it is not visible. This O1 dash nothing but here, and next one will be C dash, and within the bracket it is E dash, and finally this will be the D dash. Is the annotations properly. Now finally, so apex is O dash. Yes, this will be the first position of the problem. Next, in the second position, so it is given in the problem that it is resting on one of its slant edges. So that means O dash D dash should be on the HP here. If suppose instead of resting on the slant edge, if they have given in the problem slant triangular face, so then the same position, so we have to collinear the O dash and B dash A dash line onto the HP, right? So now select all the necessary lines. Now this lines we have to block it. Now go for the move command, take one copy of that. Now first we need to rotate it approximately we can drag this one. Now use the collinear this with this line. Now again copy all the annotations, again go for the move command and write down the annotations here. So this will become O dash now, B dash, O1 dash, C dash, E dash, and finally E dash. Now so you can unblock and you can show the dimension, that is a vertical line. Perfect. Now draw the vertical projections. Again from the horizontal projection line from all the corners. Select all the projection lines. And change the thickness to 0.05. Now zoom the area properly and connect the corresponding point. Now A will be here and our vertical A is here. Now again B to C now. So C will be here, C to now D, then D to E. So the vertical E is here, horizontal E is here, again E to A. Now from all these corners we have to connect to the O point, that is apex. A to O, B to O, then again C to O, next D to O, and finally E to O. Now so here we have to look at for the hidden edge here. So it is very clearly in this case it is very clear, that is O dash to D dash. So we have to make it as a hidden edge, because since it is resting on HP on the slant edge, so it is not visible when you are looking from the top. So write down the annotations here. O, now so A, B, now C, then D, and this will be E, and O is already written. And again we have to mark the O1 dash now. So O1 dash is here. So we have to split the line here in order to get the O to O1 distance, and take annotations, place that point right on the O1. Yes, this is the second position of the problem. And in the third position, it is axis is appears to be inclined. So whenever they say appears to be, we have to follow the normal method. So draw a line, so at an angle of 45. So you can drag it away from this. Now change the thickness to 0.05. Now select all the lines, and these lines we have to block it. Go for the move command, take a one copy of that. Okay, so take a one copy, then use the collinear, then you can drag it to the convenient position, and after that you can unblock this one. This also you can unblock and write on the annotations again. Now go for the move, copy is on, take a one copy of that one and place the annotation at the proper position. Now project from all these points vertical. There is a very slight difference between the lines B and C. If you zoom it the larger extent, then only you can see the difference. Again D, again E, and again O is here, draw that one, then complete the horizontal projections. And again from O1 also we need to draw it, so which is up to this point. Now you can trim out all these extra lines and select all the lines and change the thickness to 0.05. Then you give the fit command, go for the line, then go on joining the different lines here. Now the A point is here, vertical A, horizontal A is here. Now B point, yes, B is also here, that is the outer one. Now C point, so C will be here. Now C to D point, so that is on the XY line. D to E point, so which is here, and again E to A point. Then from all these corners connect to the apex O, so which is here. A, now B to this point, now again C to O, D to O, and E to O. Now again you join the axis line type, so from O to, so one vertical is here, yes, this will be the O to O1 line. Change this to axis line type. Get it? Now we have to look at for the hidden edges here. So as you can see, the corners E and A are most nearer to the XY line. So in this position, when we look at from the front, the edges O to A and O to E are not visible here. That's why those two edges we have to make it as a hidden edges. So before that, first we'll write down the annotation, then it will be easy to make the hidden edges. O, and C will be somewhere here. Now D will be here, and finally, okay, sorry, so we have to use a dash here. Go for the text, so that is A dash. Now this is B dash, C dash, then D dash, and finally this is E dash, and this is O1 dash, and this will be O dash. So these are the annotations placed at the proper position so that they are visible clearly. Yes. Now as I told you, so O to A, O to E, so those two lines we have to select and we have to make those two lines as a hidden edges. So this is a complete solution for the problem. Thank you.